Okay, now I'm going to work, actually from the review, it's problem 17. These are some functions that we're going to try and take the derivative of using the chain rule. So A, the first one, f of x equals 3x plus 8 raised to the 5th power. Remember, the chain rule says you sort of perform the power rule on this whole parenthesis, so the 5 comes down. You simply copy or rewrite what's in the parenthesis, and then you subtract 1 from the exponent. So that's sort of like the power rule part of it. But then you also have to then go and take the derivative of what's inside of the parentheses and multiply that by what we've done so far. So for this one, it should be 15 times 3x plus 8 raised to the 4th power. All right, chain rule. Right, not that difficult most of the time. B is 18 minus x raised to the 50th power. Once again, a chain rule is mainly used when you have, for us, parentheses raised to an exponent. So if I want to take the derivative, I sort of apply the power rule to this whole parenthesis, so the 50 comes down in front. You rewrite your parenthesis, then you subtract 1 from your exponent. But then this extra step is you multiply by the derivative of what's inside the parenthesis. The derivative of 18 minus x is simply minus 1. So when you're all done, that would be your derivative. All right, we'll keep doing these. Maybe they'll get a little more tricky, we'll see. C, 1 over 5x minus 16 to the 3rd. Now most of the time when you have something like this in the denominator, we like to move it to the top, and we can do that by simply making the exponent minus 3. Now, if I take the derivative, I can use the chain rule. The minus 3 comes down front. You rewrite your parentheses, you subtract 1 from the exponent, minus 4. Then you go inside and take the derivative of what's inside the parentheses, which is going to be 5. So this final answer should be minus 15, 5x to the minus, or 5x minus 16. And actually, since we don't normally leave negative exponents, probably best to write it like this. Negative 15 over 5x minus 16 raised to the 4th power. All right, let's keep going through these. For D, we have y equals 4x to the 4th over 3 minus 5x quantity squared. Now normally, this is one where we could probably use the quotient rule, which we're going to do, but especially when we look at the derivative of this denominator, I think we're going to have to also apply the chain rule. So let's see how this works. Quotient rule says you take whatever in the bottom, then the derivative of what's in the top, we just apply the power rule, minus the top times the derivative of what's in the bottom. Well, here we have to use a chain rule. Derivative of this bottom is we're going to bring 2 out front of the parenthesis. We subtract 1, leave it an exponent of 1, but then we also have to multiply times the derivative of what's inside. And all that over, we square the denominator. When you square a square, it becomes to the 4th. Now this is a case where we probably should try and simplify this numerator. Actually, let's do this. Let's not right away multiply out. Let's not multiply out the 3x. Let's leave that for now. So here's, well, let me just write what I'm going to do. There's the first term. This one I'm subtracting, but I got a minus 5 here, so I think it ends up being positive. I got a 5 times 2, which is 10, times 4, which is 40. Hope I'm not making any math errors. And all over 3 minus 5x raised to the 4th. Hopefully you can see I have the parentheses. It's common to all 3 terms. Here you have it squared here to the first power, here to the 4th. So I can divide out, cancel out, however you want to think about a 3 to the minus 5x from all 3 of these terms. So I'm left with 16x cubed 3 minus 5x plus 40x to the 4th over okay, what I could probably do is simplify a little bit more to finish this up. Actually, I'll just leave it like that for now.